Okay, so one of the ways I thought would be a good idea to explain some of these inscribed angles that you're going to see on your quizzes for tomorrow is to just make a video walking through a couple of the different types of problems on quizzes. That way you can kind of see the thought process and it should help you with your actual assignment. So we're dealing with inscribed angles. So inscribed angles are angles that have a vertex, like how this one's got a vertex on the edge of the circle. So does this one and that one. All these angles are inscribed. So the vertex is actually on the edge of the circle. We did before where they had central angles, which means that the center point of the circle was also serving as the vertex. In this case, these are all inscribed angles, and that's what we're doing now. The relationship between inscribed angles and the intercepted arc, meaning the arc that goes from endpoint to endpoint of that angle, is that whatever this value is, the intercepted arc is double that. So if this is 46 degrees, then this arc is 92 degrees. Whatever angle this is going to be half of this arc, and this arc's actually given to us as 128. So if this arc from C to B is 128, then angle D is going to be half that because it's the inscribed angle that corresponds to the arc CB. So if that's 128, then this is going to be half of that, so it's going to be 64. Alright, so if this is 64 and that's 128, or if this is 64 and that's 46, then we can use our rules of triangle to find our missing angle. So if we have 64 plus 46 degrees, that's going to be 110 degrees. So 180 minus 110 is going to give us 70, which would be C. So that's all you do, just select the answer at that point, obviously. Alright, so now this type of problem is a little bit more difficult. You got some algebra involved, but you're looking for angle F, okay? And then we have an expression for angle F, and we have an expression for angle E. Now, where that helps us is if you follow the actual angles, they have endpoints that are on the same point of the circle. So what happens is this intercepted arc of HG is an arc that corresponds to angle E, and it also corresponds to angle F. Since H to G is going to be the same no matter what, whatever angle or whatever degree measurement for this arc is, then F's going to be half of that, and then E's also going to be half of that. So what ends up happening is you're looking at angle E and angle F are congruent based on having the same corresponding intercepted arc. So we're going to just set these equal to each other, and that's going to allow us to solve for x. So we have 8x plus 6 would equal 10x minus 4. We would want to keep our x's positive, so we'd subtract 8x from each side. Then we'd have 2x minus 4 is equal to 6. Then we would add 4 to both sides, and we'd have 2x is equal to 10. So if we divide by 2, we'd have that x is equal to 5. So you'd want to click that answer, right? Well, not really, because that's what the angle measurement is for f. So make sure you don't do that. Solve for the x and then plug it back in. So 5, plug back into here. 5 times 10 is 50 minus 4 is going to give us 46 degrees. And I'll do some of those types of problems actually writing it all out as well. This looks intense. I'll probably show this exact problem completely broke down for you, but let's look at it. It's the same thing. They just throw in these extra ones too, just to try to confuse you, really. But if you're looking at it, still shouldn't be too confusing because you know the y's can only correspond with the y's and the x's can only correspond with the x's as far as solving these problems. That's the only way you can do it. So you know that these are going to end up being in the same equation, or you should know anyway, just by process of elimination there. But let's look at it. We've got angle B, and it's going to correspond to, of course, the arc CD, because that's where the endpoints of the angle hit. So this intercepted arc is going to be twice as big as angle B. Well, it also matches up with angle A. So A is also half as big as CD, so that means the angle A and angle B are both going to be congruent to each other. So all we have to do is 7x minus 8 is equal to 5x. Just setting it up. 7x minus 8 equals 5x. You would want to keep your x's positive. So you'd subtract 7x, or you just subtract 5x from each side. That would only leave 0 on one side. You'd have 0 equals 2x minus 8, so then you'd have to add the 8 to the other side, of course. So you have 2x equals positive 8 now. If you divide by 2, x would equal 4. Don't click 4, that's not the answer. It's asking for the measurement of angle B. So 7 times 4 is 28, minus 8 is going to give you 20. So it should be 20 degrees. Alright, so now I told you we'd do 4, so we'll do this last one here. What is the measurement of PQR? So you want this whole angle. Or no, PRQ. PRQ. Alright, so you're still going to use the angle PQR to help you with that. You are not given the arc from P to Q. You don't know what that is. Okay? So we can't use that currently to go back and find the angle PRQ, but we do have that this is a triangle. We have one angle given to us, and really this angle is not hard to find because you have an angle that has endpoints at P and R, which happens to be a semicircle, right? Well, it's not really. I mean, P2R is a semicircle. But what ends up happening, this is the diameter. So you know from here to here automatically is 180 degrees, okay? So that's 180 degrees, which means that the angle would be 90 degrees. PQR is half of the arc from P to R, right? P to R is a semicircle. It's 180 degrees. We know that because that's a diameter. It goes directly through the center point. So we have that that's 90 degrees. That's 39 degrees. So 180 minus 90 minus 39, right? Should give you 51 degrees.